Hello, worldly crazy people out there. My name is Michael. I like wizards and dragons and making games, and welcome back to getting started using GameMaker. So in the last video, I talked about basic collisions, and we talked about using the place meeting function to iterate over the distance that the player is trying to move to figure out if the path is clear or if they're colliding with something or not. And as a result, we are now able to collide with solid walls like this, and that's pretty nice. There is quite a bit more with collisions that I'd like to talk about in GameMaker, however. And I'm going to start with a function which kind of sort of does basically just all this for you. It's a feature that's built into GameMaker, and it is going to be called move and collide. So this is a relatively recent addition to GameMaker, so collision code in GameMaker since pretty much the very beginning has looked something like this. The move and collide function is a little bit more recent. It came along a couple of years ago. And it will do more or less just this for you. And it will also do a couple of other things for you. And today we're going to talk about how it works. Now, despite the fact that the move and collide function will more or less take care of a lot of your collision related needs for you, I do still think it's worth knowing how this works and why this works in the first place because, well, for a few reasons. One is that there are situations where the move and collide function doesn't work and you're going to have to write your own collision solution. And it's probably going to look something like this, maybe with a few extra bells and whistles. And also because if the move and collide function does something that you doesn't expect, which does happen sometimes, knowing what the basics of collision detection are will help you in trying to figure out what's going on and how you can fix it. So without further ado, let's actually start writing some code here. So the move and collide function will take a bunch of arguments. The first three are required. Everything after that is optional. I don't think this has come up so far in this series, but whenever you see a function argument in the documentation and it's surrounded by square brackets like this, that does indicate that it is an optional argument. Sometimes you'll see it denoted with an asterisk, but most of the times optional arguments will be denoted with square brackets like this. So this is a bit of a more involved function than most of the ones we've seen so far, but let's get into it. So the first two, dx and dy, this is going to represent the movement that you want to attempt in this frame. So in my case, that's going to be move underscore x and move underscore y, like this. You'll see it named dx. That could stand for the difference in the x position, the difference in the y position. It could also stand for the distance that you're going to move in the x direction or the y direction. If you're into calculus, it could be the dx and dy from calculus. But all it boils down to is going to be the movement that you want to attempt in this step. Next, we have the object type that you want to collide with. You'll notice that in the documentation for this function, as with most of the other collision functions in GameMaker, you can supply a couple different things, either a tile map element or a GameMaker object or a GameMaker instance or the constant all or an array of various mixes and matches of those things. I'll get to things like tile map collisions at a later date, but for the time being, let's just go with obj underscore solid to keep things consistent with what we wrote the last time. I'm going to comment this out so that it doesn't run, and now let's just go and try it out. So we can see that right off the bat, it works more or less the same as it did, as our original collision code did. We can run into solid walls like this. We can stop when we hit them. We can move diagonally and get stuck in corners. So there are a couple of differences in the way that, the move and collide function will handle collisions. There's one problem, which you might notice if you look carefully at some of the corners that I might try to run into. I'm trying to get it to happen. There we go. So I ran into this corner diagonally. I am currently holding the S and the D keys on my keyboard, so I'm trying to move down and to the right. And you'll notice that I'm not actually perfectly aligned to the right side, to the solid wall that's on the right side of me. I am sort of hovering about a pixel in front of it. And that is not super noticeable, but it's probably not what you want. I don't know exactly why that happens, but I'm pretty sure I know why it happens, but I'm not 100% exactly sure. I'll address it later on in the video. But that is a thing that the move and collide function can do that you'll want to be aware of. Anyway, for a one line of code fix, for a one line of code collision detection solution, that's not bad. So let's start looking at the optional arguments down here. So next we've got the number of iterations, and again, if I hover over the function in the code editor with my mouse cursor, you can see a little bit more documentation on it. The number of iterations. So when we wrote our collision code ourselves, we were essentially iterating over the distance that you are attempting to move 1 pixel at a time. So our movement speed is going to be like 4 or -4 on the x-axis, 4 or -4 on the y-axis. So we are going to iterate over that distance 1 pixel at a time, check for a collision. If there is a collision, we're going to stop. If there is not a collision, we're going to take a step in that direction. The move and collide function will do something sort of like that, except it'll sort of approach the problem from the opposite direction. And instead of saying that we're going to iterate 1 pixel unit at a time until we either reach our destination or hit something solid, the move and collide function will instead take a certain number of steps toward its destination. The default value, because the number of iterations argument is optional, the default value is 4, which means that the move and collide function will move whatever distance you want it to in 4 discrete steps. And that just so happens to align with my current movement speed, and that wasn't something I really planned on when I set out to do the original collision code video, but it just happened to work out that way, that a movement speed of 4 felt about right for that demo. Anyway, what this means is that we're going to try to traverse a distance of 4 in 4 steps, which means that every step is going to have in every step we are going to move a distance of exactly 1. If my movement speed was slightly higher, say 6, the math would come out slightly differently. We would still be moving in 4 increments, but each increment would be a distance of 1.5. GameMaker does allow you to do collision checking with fractional numbers, which sometimes is what you want and sometimes isn't. If you're getting started, I would honestly probably recommend trying to avoid doing collision detection with fractional numbers, but there you have it. You can increment this. Increase this if you'd like. If you think you need a higher degree of resolution in your collision detection, you can set the movement step to, for example, 10 iterations, and whatever distance you try to move, GameMaker will do 10 collision checks along the way. So if I move 4 pixels of each individual check will be 0.4 pixels at a time. My recommendation would probably be to try to keep it to the number of iterations just being the distance that you're trying to move. So if your movement speed is 4, make it 4. If your movement speed is 8, make it 8. So circling back to the problem that we saw earlier with diagonal motion sometimes getting stuck weirdly in corners. So if I'm moving diagonally, if I'm trying to move, for example, up and to the left at the same time, in that case, my movement on the x-axis is going to be -4, my movement on the y-axis is going to be -4, and the total distance that I'm going to try to move is going to be the hypotenuse of a triangle with side lengths of well, 4 and 4, which is going to be a distance of like 5.6 or something like that. And 5.6 is a distance which is not an integer. It has a fractional part, and it does not divide evenly into 4. And I think what is happening is that GameMaker will do 4 iterations in its process of checking for collisions. And each step is now going to be a fractional amount. And when you try to move into a corner like this, there is a chance that you'll just be off by some tiny fraction of a pixel. That is one of the reasons why collision detection with fractional coordinates kind of makes life worse sometimes, and you might want to avoid it if you can. In that case, you can make sure that the total distance that you move is going to be like an integer amount. You can round your total movement speed to an integer. That's going to involve a little bit of math, normalizing this vector and making sure that it has a unit length of like an integer, that sort of thing. You can also just increase your number of iterations, and with a more fine-grained movement step, the odds of getting stuck in a corner awkwardly are going to be greatly reduced. It probably isn't still impossible. Just the amount of error that you'll see is so much smaller that you might not actually notice. It'll be too small for you to really be able to see by eye. Anyway, that's the deal with the number of iterations. I guess I'll leave it at an iteration count of 10, because it seems to, Oh, you know why I was moving faster than I thought I should? Is because I forgot to comment that back out. Yeah, that's the movement speed that I thought we should be moving at. Alright. Alright, so that's the number of iterations. Let's move on to the next couple of optional arguments in the move and collide function. So, before I talk about the X offset and Y offset, I think I will talk about something that's pretty interesting that the move and collide function will actually do, and that is collision avoidance. So if I were to rearrange the furniture in this room over here, and if I were to just create a solid vertical wall like this, and I've gone ahead and added two additional sprites to this project. One of them is a 2x2 orange square, and one of them is an 8x8 orange square. And I'm just going to use this as like smaller versions of the wall tiles. If I were to go and set the sprite index over to the 2x2 square, if I were to go and use my original collision code, we would, if we run into this obstruction here, we will not be able to move past it, even though it is definitely like very tiny. And that is because that our original collision code isn't really doing any complicated collision avoidance. We're just moving the object's like collision shape, and we're testing if there's an overlap with another shape, and if there is, we can't move. And as a result, I can't go around tiny obstacles like this. However, the move and collide function will do something pretty interesting, and that is collision avoidance for you. So if I were to go and use the move and collide function, if I were to run into this tiny little obstruction here, I will actually go around it. I'll just sort of bump over it and go around it, and we'll continue on our way. And that is honestly pretty nice. So this is something that is not impossible to code on your own, but it is definitely more work, and it's one of those things that I just don't think is fun to do. However, there is a limit on what you can actually go around. So if you have an obstruction that's too big, the move and collide function by default will not let you go around it. If I go and switch this over to the 8x8 orange sprite, and if I run the game now, we'll see that this is too big, I can't go around it. And the size of the obstruction that you can go around is proportional to the magnitude of your movement. So if you're moving faster, you will be able to go around larger obstructions by default. The offset X and offset Y values are there to allow you to customize how far you can do that, like if you want to be able to avoid larger obstacles. However, what exactly they are is not quite as straightforward as just putting in a big number like 10 for the offset X and offset Y. What these are is, I believe they are the cross product, the 2D cross product of your movement vector. So the 2D cross product of these by default. If you know how things like perpendicular vectors and cross products and that sort of thing work, and you're fine with working with those, then feel free to insert your own values into here and see what happens. Otherwise, I'm probably going to recommend just leaving them alone, leaving them as the default values, because I think it's good enough most of the time. The default values for these is going to be 0. If you put in 0 for these, then GameMaker will just do its default thing. I will not be able to go around this obstruction, but I will be able to go around this obstruction. And this is going to be the optional value for the offset X and offset Y. Related, if you do want to just ignore an optional argument and move on to the ones that come after it in the parameter list, GameMaker does allow you to just insert empty commas in a function argument list like this. Feather will complain at you, so the syntax checker will complain at you, but it will work. That is a bug in the syntax checker. Ignoring the red squiggles, I can still run the game and it'll still work here. But just a fun GameMaker fact, you can also, in this case, just type in the default value, which is 0. Undefined will also work. Anyway, lastly, we have move underscore X and move underscore Y. This is going to be the maximum distance on the X and Y axis that you can move in a step. And at first glance, this sounds kind of useless because, like, wouldn't the max distance you can move in a step just be your dx, dy values? But there are some situations where that might not actually be the case. For example, if you do need to move around an obstruction, it is possible that you will end up moving a greater distance on the X or the Y axis than this value. For example, in this example, if I'm trying to move, like, around this obstruction here, even if my Y movement value is 4 and my X movement value is 0, if I go around it, I'll have to move on the X axis like 2 pixels, and that motion would be greater than the dx value. The max X movement value and the max Y movement value is just the upper limit on how far GameMaker can take you. By default, there is no upper limit. But if you want to insert an upper limit, then you can do so. The documentation here says if the value is less than or equal to 0, no clumping will be performed. But I think that's actually wrong, because I definitely have accidentally put in zeros here before, and when you do that, like, I just can't move. If I were to insert instead -1 for these values, then this will cause it to allow me to move, and it will cause there to be no, like, upper limit on how far I can move. I'm pretty sure that this tooltip is actually wrong. I should probably report that. Anyway, um, so examples of places where this might be important is if I do want to go around an obstruction, or if I want to not go around an obstruction. If I set the max X movement to move X and the max Y movement to move Y, then I will only actually be able to move, like, based on my input movement. And I won't be able to move on the x-axis to go around an obstacle, or I won't be able to move on the y-axis to go around an obstacle. And if I run the game now, and if I try and go around this little tiny pebble, I won't be able to, because our movement is limited on both of these axes. The example cited by the manual for why you might want to do this is if you're making something like a platformer, and if you're falling really fast, and if you hit the ground really hard, you might inadvertently transfer some of your momentum into the horizontal direction. I can't say that's something I've ever run into, because I don't usually make platformers, but if you do, I don't know if that's a common problem to have. You might consider implementing an upper speed limit. And if there's ever any other situation that you find yourself in where this becomes a problem, you can use the max X movement and the max Y movement values as to impose a speed limit. These last 4 arguments to the move and collide function honestly probably aren't something that you'll really have to worry about most of the time. I think the default should be fine for most games, but if you are doing something very specific, and if you do need to tune the behavior of this function, then it might be worth investigating those and see if they work out for you. Now, that's about it. Before I go, I did say that there are some places where the move and collide function just won't work. Probably the most common one for people to run into that I've seen is if you are making a platformer, and if you're trying to make something like a one-way platform, then the move and collide function won't really behave there, because if you run into a one-way platform, the correct behavior for whether or not you should stop when you hit it depends on, like, if the player is going up and down, up or down. If the player is going up, you want to be able to go through it. If the player is going down, then you want to stop when you hit it. And, like, I guess you can kind of hack your way around that by being very particular about what the object that you're checking for collision with is, but it's probably at that point not really worth trying to make move and collide work. Other examples might be if you have some other kind of solid object whose behavior when you run into it is dependent on some other state in the game or some property of the object. Like if you have a wall which is normally solid but can become transparent based on some condition, the move and collide function is not going to be very elegant for handling something like that. And again, you can hack your way around having to deal with that, but at that point, would it be better to just write your own collision code? Probably. So with that, I think I'm going to end this off here. Let's see if I put this room back together. My name is Michael. I like Wizards and Dragons and making games. The sprite index override for this object here was not saved in the undo buffer, which is another bug in GameMaker that I should probably report. I like to post videos on all kinds of stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. And if you felt like pledging, I definitely would appreciate it. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, Zach Robinson, Squarecrow, Spydeye Games, Pixelated Pope, Paradox, Nykotic, Manta Ray, GameMaker, Gamer Indie, Edward Holt, DJ Gibbles, Brenton, Bokeh Dev, and Argo the Knot for supporting these videos. If you want to join the ranks of these very cool people, head on down to the Patreon page in the video description to join the fun.